You get it? So extend this one, my brother. There is a reason for that. You get it? There is a reason for that. I'll tell you later. So just extend it a little bit. You understand? So now we have to get 0.4, which is 1, 2, 3. So 0.3 is the true reflectional point through your what? Your y-axis, if I may call it like that. And then now we are going to reflect 0.2 through our horizontal line through our x-axis. So by making use of what? Of r. So place it at r, further extend to what? To 2. There is my 2, eh? So now I come and mark it here. Understand? So which means from R to this point is the same as from R to point 2. You get it? So which means it's going to be that one, 0.4. You get it? So now join 0.3 with 0.4. There you go. Don't stop here. Further go down. You get it? You understand? So now 0.4 back to 0.1. That is very much important. 0.4 back to 0.1 using your 30 millimeter ruler. So these are straight lines. So every time you draw a what? A straight line, you use this. You don't stop here. Further extend it down. You get it? So where's your question? So we are done with the what? With the constructional line of an ellipse. We are done with the constructional line of an ellipse. Remember, they said to copy the given diagram using a scale 1:1. ABC is a half of an what? Of an ellipse. So ABC, which is ABC, is a half of what? Of an ellipse. Which means CD back to A. It mustn't be there. So as much as you can see, like as I've said in the beginning, that geometrical construction, basically what we do there, we are drawing the given view, the way that given diagram of view, the way you see it. So the trick here is to just to draw and following the what? The scale given. So now I'm going to use a number to an alphabet to a number. You understand? So I'm going to use what? I'm going to use point A further extended to what? To point. Point 1 further extended to point A. So now I draw dark till at the line of Roman figure 1 and Roman figure 2. So it's the one that is guiding me where to stop. You get it? It's actually the one that is guiding me where to stop. You understand? So now what I've done here, I come and do it this other side, place it at 0.3, further extend it to C. Then have it dark, like this. Dark. So if it was a full ellipse, we're going to go up until here. You understand? We're going to go up until here. So it's not a full ellipse. You understand? So now to close it up there, you place it at what? At 0.2. Further extend to point what? Point B, which is a number, which is 0.2, to an alphabet, which is point D. So now, B, not D. There you go. Just a little bit. There you go. There you go. Yes. So it's coming. So dark till here. Everyone, dark till here. You understand? So now, that is why, my brother, I was like, don't stop here, further extend it down. So it is the one that is going to give you, that's where the marks are lying actually. So they will check, is it your ellipse touching nicely there, or is what? You understand? When they mark, that's where these are the crucial point. These are what from A to C. Is it the real 100 millimeter? You understand? And then these are what? A crucial point. These are crucial points that you have to take note. All right. So now, what is going to happen now? Remember, it's now a half a cycle. So we are going to end with what? With that hexagon. Hexagon of 15 millimeter. So we are told, my brother, from point C going down, we want to draw what now? That diameter of radius 20. So from here to the center is how much? That is why I prefer hard copies. I think it's 60. If it's 60. So remember, we don't just draw we don't record a line in the middle of nowhere, which means I must first construct a line. There you go, down you go. So after I have this constructional line, I can then record what? 60. 60 uphelela kuphi? Nanga laphelela khona. And remember ukuthi lo 60 lo ukunikeza ini? Ukunikeza center line of that. So Mdwebek, how do you draw a center line? Long, short, long, short, long, short, long, short, long, short. You get it? And then check it nicely then. So we are told ukuthi from here to the vertical one is how much? Uzo record 20 millimeter. Usuka kuphi? Usuka la uye on your left hand side. But ubani 20 millimeter, my guy. So 20 millimeter using a scale 1:1 on it. There is my 20. So I simply mark it what? It is 0. You get it? So I can put the what? The vertical center. So get to the exact point. So I can come back here to extend this one just a little bit. Get it? Right. So they are saying using that point, record what? R20. So using a scale of 1:1, so I'll simply record the R20, which is what we've already recorded here. So you simply open your drawing compass. Remember that R20 is the same as this dimension 20. So radius 20 millimeter, which means you want to draw diameter what? 40. Everyone. There it is. Then you draw it solid. Solid dark. There you go. You get it? So now I can simply have this one dark from here till there. A1. Which is which one? This one. It's that one, my guy. From here till there. You get it? Okay. So now let's go back to our starting point, which is point A. So from point A to come this side to get to the vertical of this one, they said so much is 10 millimeter. Yeah, you know, this phone is crazy sometimes. So it's how much? It's 10 millimeter. 10 millimeter. So I'm going to record the 10 millimeter. Put it at 0. At point A, I mean not 0. There is my 10 millimeter. Then I can draw the vertical center. The vertical center line. After I've drew the vertical center, so I can come back and be like, from here till here is how much? Because they set radius 15. You understand? So which means from here going down, I'm going to record 15. Radius 15. From here till here has to be 15. From here till here has to be 15. From here till here has to be 15. So in other ways, we were drawing what? A diameter, what? 30. So take my drawing compass. Drawing compass, open it to 15. There is my 15. You understand? So I can come here, place it here. Where my 10 ends, I just mark. You get it? You understand? Where I've just marked, I can draw the horizontal constructional line. Horizontal center line. You get it? And now, draw it. Remember, it's going to start to be dark from here till here. Dark, 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 dark till here. You understand? So this other part is going to be faint. It's going to be faint even if you don't draw it. So your center, it mustn't end like this. So I have to come back and just exceed it just a little bit. Because our center line always exceed our drawing. You get it? right. So from there, my brother, we are going to get this axe of ours. Okay, now this axe of ours, they are saying, is actually touching this circumference of this one and this one, and you open your drawing compass to what, to 100. So which means we have to use the try and error method in this case, because we are not given the reference point of these angles. A radius 100, reference angle, we are not, reference point. So I will simply open it to my 100 millimeter, which is something big. Radius 90. I go to what? 100. There is my 100. You get it? So I'm actually looking for a point that way when I'm placing this one from here till here, from here, okay, I trace it. Do you see that it's not touching? So let me just mark where at this point, so that I construct this point horizontal now. Faint. So now I'll come back along this point. You see, it's now, which means I have to go a little bit back. So there it is. But then it's now all right with this one. But there is not coming all right. You understand? So which means at this second point, go vertically down. At this second point, go vertically down. Faint. I'm tracing the reference of this point on it. So now, isn't it? It was here. Here is coming all right. But then go just a little bit down. There you go. So yeah, I'm getting it, but I have to just comb the side a little bit. Faint as well. Trace it. There it is. And then so you can actually see it's coming. So now, which means the exact point is that one. You understand? So now I can have it solid from here till right there. Everyone, dark like this. How did I trace it? You have to trace it. You simply open your drawing compass to that particular radius that they spoke about, and then you place it along. You must firstly get a one point, and then from there you rely to that point. You keep on tracing. We started here, then from there when we place it here, we saw that okay, it's coming there, but here it's not coming. So we had to rely on it in terms of horizontal. Understand? Then we got it. Then now we saw okay, when we place it here, this side is coming, but on the first side, it's not coming. But when we place here, it was coming, it's not coming. And then place it here, it's coming, it's not coming. So we had to go down so that automatically on this one. So that's how we got it. So let's get to the second one. So we trace it, try an error method. You trace it like this because we were not given the radius reference point. If I'm saying the reference point, I'm actually saying, do you see this is radius 20? So we are told from here till here is what is 20. You understand? It's 20. So you construct a vertical center line and a horizontal center line. So you've gotten your reference of that reference of that R20. That okay, throw this radius 20, putting your drawing compass there. So again, this one radius 15, we were given the reference point. We're told from here till here is how much is 10. So but with these ones we had to trace it because we are not given the radius. So the reference point to draw the radius 100. So again in this one we have to draw radius 80. So trace the reference point of that radius 80. What you know, it has to touch here, it mustn't cross, it mustn't be nearby. It has to touch, like a line in mathematics, they call it what? A tangent. It's a line that touches the circumference of the side. It's not passing by, it's not crossing. You understand? It will be just touching. So now, in this case, you, my brother, you simply open it to what? To 8. When I'm striking this arc, what I know, which it has to start here and till here. So I can place it anywhere. Do you see that if, check this, if I just place it anywhere, do you see that it will be not touching there? It's still not touching there, which means go up a little bit, go up a little bit, go up a little bit, but putting your pencil lit there, you understand? So like this. So now let me see. You see that it's not, this side when at my starting point is correct, but at my end point is not correct. It's not correct. Is what is actually crossing. So which means I must go, just mark, I've marked this point now, and I've marked where it is. Where's my pencil? Is which one? Is this one. Okay, this side is correct, but it's that point. So which means I can take this point horizontally, faint. Understand? So now I'll be placing it along this horizontal line, but putting my pencil lit here and keep on checking what is it coming. You see that it's not coming, but up there is still coming. So which means I must go back just a little bit. There you go. Be accurate. Go back a little bit. There you go. So now I can draw dark. Draw dark. There you go. There you go. You get it. So you must always look for a method, the simplest method that you'll prefer. So where we're placing our drawing compass right there. So which means this is the reference of this angle 80. You understand? So I can shoot it like this. I was placing my drawing compass actually right here to draw this what? Radius 80. You get it? And then I was placing my drawing compass right here. When I'm drawing what? Indicate by an arrow. When I'm drawing radius 100 millimeter. You get it? So from there, what is left, my guy, is what? It's a hexagon. So we've got two different types of hexagon. We've got a flat hexagon, we've got across the flat hexagon. So, and remember the X is what I've named R. So also name it X, because the X is what is given right from the what? From the paper, from the given, you understand? So now what we are left with is to draw the across the flat hexagon. So we've got so many methods of drawing this. So you select the accurate and simplest one for you. So in this case, we know the properties of what? Of a hexagon. All the sides, they must be equal. It has got 6 corners, which is 1, 2, 3, 4, 5, 6. A hex means 6 on it. So we are going to just take, so which means if it's 15 from here, it has to be 15, has to be 15, has to be 15. You understand? So take your drawing compass, simply take your drawing compass, open it to that dimension which they are saying your hexagon is supposed to be. You understand? I'm trying to be fast now because we know how to draw a hexagon. So simply place it at 0, open it to 15. Because at the end of the day, I want to get what? A hexagon of 15 millimeter. This is it. You get it? So now I'll place it at my X point or R. You understand? I'll draw a faint cycle. So you draw it faint because it's not part of a what? Of a hexagon. So now I can come. Let me get the what? The exact point there. You get it? So from there, my brother, what do? You take a drawing compass. Since you want to obtain a flat hexagon, you're going to stick on a what? On the horizontal center line. You place it here, further extend it to the center. This is it. Then now you come, is just strike an arc here and strike an arc there. You get it? Then you come to this other one, place it here to the center, you strike an arc here, you strike an arc there, crossing your this line of yours. So now you can simply take your 30mm roller. Before even that, these two lines, they must be at the same point in terms of what? Of the horizontal. Again, this one, the same straight line in terms of the horizontal. You get it? Then from there, take your 30mm, you join this one with the center, you join this one with the center, you join this one with the center, you join this one with the center. You get it? So now let's check. If we measure from here till here to get 15, from here to here to 15. So this is 15mm. This is 15mm. So there is my 15 and it. This is 15mm. You understand? So this is 15mm. So which means our hexagon is what? Is correct. Let's see, is there anything we've left? Yes. That 10 from here till here has to be solid. Everyone has to be solid from here till here, which means from here till here. It's a metal plate. So from here till here has to be solid. Right, so I've gotten it. So thank you very much, guys, for watching. That was Mr. Nkosi for engineering graphics and design grade 10. I'm sorry my brother to take long, you understand. So assessment criteria: ellipse a 15 marks, a cycle and lines 8 marks. So they need to see the dimension, the constructional line. So the curves 10 marks, hexagon 6 marks. The total is 39 marks. So thank you very much, guys. See you on the next video. Bye, thank you.